This show is produced by the Hartman Media Company. For more information and links to all our great podcasts, visit hartmanmedia.com.
Welcome to The Commercial Investing Show, where we analyze, explain, and exploit the opportunities presented in today's commercial property marketplace. If you're interested in apartments, mobile home parks, self-storage facilities, and other income property, you've come to the right place. We'll explore what's hot and what's not in markets nationwide in the relentless pursuit of return on investment. Here's your host, Jason Hartman.
Welcome, everybody. It is my pleasure to talk to you today about 3D printed housing. I have been following this for over 10 years in terms of the housing aspect of 3D printing, but I've been following 3D printing technology for maybe, 17 or 18 years. I've been fascinated with it. And it's coming. I'm not sure if you're going to hear it's quite here yet for housing. Maybe you will. That's up to what Jarrett says. But we've spent a lot of time researching his content and talking to him. It's just a great pleasure to have him here on the show with us today. Jarrett, welcome. How are you?
I'm doing well. How are you, Jason?
Good. You're coming to us from Austin, Texas, right?
Yeah, this week I'm in Austin, Texas. It's been different almost every month this year as I've been chasing different 3D printed construction projects around the country.
Right, and around the world, actually. So I'm sure we'll hear about that. We're going to look at some of your videos, and you've just done a great job at this. Where do you actually live? Do you live in Austin?
I'm originally from New Jersey, North New Jersey, kind of by New York City area.
Give us a little bit of your background. I mean, you are not in the 3D printing business per se, and it's not really your background, is it? But you became fascinated with the technology, as have I. How did you come to this, and what tell us about your education and such?
Yeah, so in the past years, I've worked construction labor jobs, construction management jobs, starting in college. And I guess it was around a similar time that I really discovered 3D printed construction from a Facebook video, one of those like $10,000 house videos, which turned out to be a myth, but a myth that
they're a total myth. I've seen those too. And everybody sends them to me and say, Jason, isn't this going to disrupt the housing market? No, I don't think so. But
yeah, a lot of people complain about that often, and it's definitely the result of some poor journalism, but it's something that I'm almost thankful for because it was like a clickbait that really spurred the industry. And without it, I don't know if so many people would have gotten involved. I don't even know if I would be involved. So thanks to whoever wrote that misleading headline.
Right.
After doing some more research, I discovered the $10,000 house was a myth, but I was still enthralled with the technology and the idea of automating construction, especially with all the economic factors right now in the construction labor force and the construction materials costs rising. I just think that at some point down the line, there's no way construction won't be automated. So I want to be there when it happens.
Right. Good stuff. So what are you doing now then? I mean, you're consulting with us, which is great. We had a consulting call with you yesterday, and you've given us a lot of tips and insights into the industry. I'm fascinated with it too. I have been for a long time. What do you do now?
Right now, I'm going to these various projects, and I have my own podcast where I have the CEOs of companies that are either building 3D printers or construction companies doing the projects, just to try to talk about and expose some of the details that people aren't necessarily privy to. I guess in the beginning, it started with I paid $30 to WinSun to get a tour of their facility. Didn't really know anything about videography or cameras or anything, but I knew that I was there at the site, and that was an opportunity not everyone got to have. So I thought I could share that with people. And after that, it kind of had like a snowball effect where that got some views, and the views then gave me more exposure to more companies. And now it seems like I've just kind of become the YouTube guy for 3D printed construction.
Sure, that's great. And just so listeners and viewers know, WinSun is the Chinese company that has built the largest 3D printed home in the world, I believe. I spoke with them last week and had an interesting call with them as well. Go ahead if you're ready and share your screen, and you've got some videos to share with us today and a couple of charts and graphs too, I believe, and we're looking forward to seeing that.
Here's the very first video that I ever posted on YouTube.
I'm here at the WinSun facility in Shanghai, China.
So in this facility, I got to see all the different stuff they've printed. They had a lot of small prints. This is some stuff that would go in the ocean it's actually like a retaining wall that you might see at a jetty or something like that.
Mm-hmm.
They've experimented with all kinds of different things. They had $200 million of funding. So with that money, they basically just printed everything they could, trying to figure out where the best value propositions were. This is a smart toilet that operates with like mulch.
That doesn't have anything to do with 3D printing the toilet, right?
The building is printed, the toilet's not.
Okay. Yeah.
I think that's meant for like third world countries without access to plumbing necessarily.
Mm-hmm.
So then you go on to these 3D printed houses that they have. They're like little studios kind of.
Actually, let's just pause for a moment. Maybe some people don't even know what 3D printing is, okay? So let's just explain that contextually. This is also known as additive manufacturing, okay? Where basically, think of like an inkjet printer that you have printing on flat paper. Well, this prints in 3 dimensions, where it basically prints maybe with concrete or other materials, composite materials, even metal, and it can build a 3-dimensional structure. 3D printers are used to build a lot of small things now. I was talking to an orthodontist recently, and he 3D prints retainers for your teeth, your mouth, and so forth. But these are 3D printed houses, office buildings, things like that. Is there anything more you want to just say to tell people what 3D printing is before we dive in too deep?
Yeah, I think most people have heard of typical desktop 3D printing in plastic. To consider this, they just have to scale it up in their minds. And most of these printers are just large versions of that, a kind of a gantry system. And instead of plastic, you're printing in concrete. And so it doesn't harden immediately. It's not heated at the extruder head. It does emit heat because as concrete cures, it emits some heat. But the process, while being very similar on a macro scale, there's a lot of subtle differences that I don't think are too important for the average listener.
Great. So go ahead and show us more in the video.
Yeah, so the homes that they had in China, they said these were built for $10,000 each. I'm pretty sure that was a claim they made just to be on par with the other company's publicity, unless it's just coincidence. I don't know. But they're not mass producing them. China's amazing at construction. They're known for Shenzhen speed is 1 floor a day they'll build.
Right.
So they're definitely some of the biggest innovators, but this is all within their facility where they're experimenting with this technology, not being brought into the real world. Here's some foundation work that they're doing with printed concrete that was printed off-site and then brought on to the facility. And then they also have a really big building that they're working on that uses mostly precast concrete and some printed columns and mostly just decorative stuff. So as we go into the next slide, you can see around 1996, Contour Crafting claims to be the first company to do kind of contemporary 3D printed construction. There was one patent from a guy in the 1940s for a concrete printing apparatus that never really got off the ground, but it's tricky because a lot of people claim to invent it, have the first 3D printed house. It's really difficult to truly track back the origin or the true inventor of who did it first. In 2004, Winsun develops their print nozzle. And then since then, recently, the number of projects has just skyrocketed. And now tons and tons of people are getting involved.
Okay, so it was really Winsun in 2004 that had the print nozzle for like residential construction, right? Before that, 3D printing was pretty much a desktop type of application, right?
Yeah, that's valid. I think there were other uses for 3D printing that were maybe more large scale. Autodesk has invested in a bunch of companies doing different types of materials and different scales. But Winsun was definitely early to the game. Not as early as Contour Crafting, obviously, but when it comes to housing and building real estate, Winsun was pretty early to the game there.
Okay, great. Before we get too into the weeds on, what's going on with the industry, you just have tremendous insight on all this stuff, and we're glad to have you to share it. But let's just kind of back up and talk about the macro view and like what this means to people watching and listening to this, what this means to real estate investors, what it means to, for affordable housing and so forth. Because, one of the key components of real estate value for an investor's property, for example, is that there is a cost to build it and a cost to create it, and the land has value. The big question is, would 3D printing disrupt this and make it a whole lot cheaper to build a home than it is today? And this is very misleading, folks. I actually kind of wish it were true because I think it'd just be really good for the world, and I think would give people a lot more discretionary money to spend on a lot of other things, or to build more fabulous houses than they live in now, and so forth. But, when you hear these prices quoted for that $10,000 home, that's just for the structure, right? That doesn't include plumbing, electrical, foundation, land, engineering, all kinds of other stuff.
That's an imaginary number for publicity. Even the structure may not necessarily be achievable at that cost. The material, because it's made in such tiny batch sizes, it's a custom concrete, it's quite expensive. I hear what you're saying completely, and that's my vision ultimately for the industry, is an affordable housing solution. If it doesn't get there eventually, then I definitely chose the wrong field. But I'm thinking that it's kind of like the light bulb. So after they invented the light bulb, whether it was Edison or he stole the idea, whatever.
Probably stole it from Tesla, but okay.
After making it emit light with electricity, it took 100 more models to achieve a light bulb that was cheap enough to be adopted by
commercially viable.
Yeah. Right. So I think this is kind of similar, where we've had a couple 3D printed houses. Maybe there's like a half a dozen overseas. Now we have 5 in America. And I really think it's going to need to hit that 100 mark to really discover all of the various efficiencies and mine for the value that this technology has to offer.
Okay, that's good. So, I mean, the $10,000 house, is that just a complete lie then?
Yes.
Yeah, okay. Are they somehow kind of, fudging on that number? Like they couldn't even build the structure for it, you don't think? Because it's not just regular concrete, it needs to be a special type of concrete?
Well, the thing is, it wasn't the companies that were claiming to have built a 3D printed house initially. It was some journalistic outlet. When I talked to Icon, I think they had said there was like a claim of a $4,000 house, but that was a rounding error. It was supposed to be, they missed a zero. It was supposed to be $40,000.
Wow.
And that was for the structure it wasn't a complete build. It didn't include the land, obviously, or the utilities necessarily. And so it's not a lie per se. It's not that these companies are trying to deceive, but it's just that what catches the attention. Like somebody wrote that article, it probably got 10 times more clicks than it would have if the number was accurate.
Yeah, sadly, that's the world we live in. But yeah, it's a world of hype. Okay. All right, let's go ahead. Anything else you want to talk about on this chart?
No, I think that's all. This slide and the next slide really just demonstrating the increase in interest. This is the Google search traffic. So you can see back in 2016 or 2015, relative to now, the traffic was very low for 3D printed houses. And then this is right where the $10,000 house article came out. So there was that huge spike right there. This might have been the $4,000 house claim, but either this one or this one, these were the two big journalistic pushes many years ago. This is around the time I discovered the technology. So since then, it was kind of flat. But recently, with the announcement of the SQ4D printed homes in New York and the Icon homes in Austin, there was a spike again, and it's a sustained spike. So the traffic has been consistently like 4 or 5 times higher than it was before. So when you see trends like this in Google search, a spike, but not just a spike, a sustained spike, it generally is a sign of a trend that's emerging in the world.
Okay.
So now here's the first house I visited in America. This one was conveniently located only an hour and a half away from my home. So I took some drone footage and walked around the interior. It was built by SQ4D with this printer here. It's disassembled there, but before it had been much taller, obviously, and it's on tracks. So the tracks were set up lengthwise at either side of the building. And had they wanted to, they could have extended those tracks to infinity and printed as many homes in a row as they had wanted.
Right. Either one huge structure or a whole bunch of, this could be a way to develop subdivisions where you could just put a track and go down and print one home and then print the house next door and the next house and the next house. It's like when I went to the Toyota factory in Japan, that was just so impressive how different cars, they go down the line and the robots can just assemble a completely different kind of car. And the next one's completely, they're not all the same. They're not all Model Ts, right? It's amazing how specialized they can be. And here they're building the 3D printed structure except the roof, right? The roof is traditional, obviously.
Yeah, the roof is just a typical, this is like a barn roof or something like that. Different companies, use different roofing solutions. It's not something that's been innovated or really considered much because there's still so much work to do with just the printed walls. So they have a few walls in here since then that they've spackled over because, I mean, I don't know if you can really see clearly, but in the back, it's not like the smoothest lines necessarily. Mm-hmm. They printed outside without a tent. So they can finish this with like a shotcrete or a spackle and get just a typical smooth concrete finish.
So what are some of the challenges they're having? Like you mentioned, the walls are a challenge enough. They can't do the roof in 3D printed. They do have concrete roofs, by the way. You know, I've researched this. And for example, the beautiful, famous Sydney Opera House in Australia is a concrete roof. So that is something that is done. Tremendous insulation, by the way. What are the challenges just with the walls? I mean, getting them even, getting them to look good. Of course, if it's the standard 3D printing, it's like we see on the screen now. They've got these sort of layers of like a tube of toothpaste if you were squeezing it out and putting another row on top and another row on top of that. It's definitely not what people expect in a traditional home.
One of the big things is balancing the cost of the material with decreasing the likelihood of a crack. So concrete cracks pretty much by law. It always cracks eventually. And whether it's a microfracture or a noticeable fracture, it's pretty challenging to have a concrete mixture that won't crack. And you can put supports in, rebar supports, fiber supports, but unless whatever you're supporting it with is in tension when the concrete is cured, it's not going to prevent a crack. It's just going to keep it together after a crack. So people obviously aren't going to be comfortable with visible cracks in their home, and mitigating this, whether it's with some kind of paint just to go over it or something you fix after the fact, that's a pretty sizable concern, I would say.
Mm-hmm. Okay.
So this is a project from a company called Emerging Objects in Colorado. They are printing in mud. This is really unique because it's obviously really cheap. They're able to dig up the dirt that's local around where they've printed. And by mixing it with water and straw, they're able to extrude it from a printer and get this result, which when you look at concrete, it has cement, which emits CO2. This is like the most sustainable option and the most low cost option. Now, obviously, it's a mud hut.
How is it strong enough?
It's actually surprisingly strong. The mixture is called an adobe mixture. And historically, it was used in kind of like this region in Colorado by people that back then, Texas and Mexico wasn't such a fine line. And it was like almost not Native Americans. I'm definitely classifying it wrong, but people lived in huts that they made out of this adobe structure. So it's been used for many, many years. And after it rains and then dries out, it actually continues to get stronger. Is it a solution for a house that you or I would live in? Probably not.
Right. Okay.
So this is a project.
Fibonacci. I love this. Are we going to talk about the golden ratio here?
We can a little bit. So 20 Additive Manufacturing is a company in Canada I was really lucky to visit. This is their facility in the front there, and then in the back is where they printed the Fibonacci house. They really like math and the golden ratio. Right. So they designed this house to, I guess, have all those characteristics. And theoretically, it's an optimal living space for up to 4 people.
So, there are some who build and design houses around and want to live in houses based around feng shui. Some who just want a nice floor plan, whatever that means, right? And there are certain things that make a good or bad floor plan, of course. Now it's Fibonacci, and your house has to follow the Fibonacci sequence. That's a pretty tall order. But this doesn't necessarily have anything to do with 3D printing. It's just easier to do this on a 3D printer. This could all be done with traditional construction, although it'd be very difficult and very expensive.
Exactly. That was the point of this project. It was to find a way to make 3D printed construction more efficient than traditional construction. And this is their answer to that question.
Right. Okay.
So this is their printer. They operate it within this facility. Since then, they've made a model that operates outside. They call it Telecom. So before the concrete prints, they need to extrude the material, make sure it's the right consistency. There's 2 different types of material. You see this one with the red extruder that was over here is a 2 material print. And so that one has the regular concrete and then an accelerant. The unique part about this is you can print in arches because the concrete will harden instantly because of the accelerant. This method is 10 times more expensive per cubic meter than typical concrete.
but it does allow you to do some really cool architecture.
Incredible stuff. So this print head, just the plain gray, is just a one material print, which is much more cost effective. Here they're printing a sign for a playground. This is a Kootenai salmon. It's like an indigenous salmon to their region. And it's anatomically identical to the actual fish. So they took an outline of the fish and then imposed that on a software, and then with an outline created this exact fish model. And so is that possible with other methods? Possibly, but if you want it in concrete, creating that perfect form.
Really difficult.
Really difficult.
Yeah. With the 3D printer, you can do a lot of really interesting shapes. In fact, most of the construction that you see when it comes to the few single-family homes that we've seen out there have rounded walls. There is one company I remember that you profiled that actually makes square corners. It's more like a brick shape. I think they do 3D printed bricks actually, right?
Beta Bram they like slice the edges of their print, and that gives them really sharp edges. There's another company, Fast Brick Robotics, that I guess they make the bricks off-site, but they load the bricks on pallets into a truck. And then that truck with a boom arm that stabilizes to a laser in the corner of the build site lays the blocks down in the exact pattern that will construct the building, kind of like cinder blocks or bricks. And they have indents in the blocks for the wiring and the plumbing to go in the future. So theoretically, it makes everything just like plug and play for all the different subcontractors.
Sure. And just to go back to the cost thing for a moment, I know you've got a lot more to show us and can't wait to see it. You know, it seems, Jarrett, that really the barrier here on the cost is simply the cost of the actual materials and also getting the machines to do the job right, which they're not there yet, it sounds like. Not quite there.
I would say the machines are there. The material has a ways to go.
Okay, so it's the material, not the machine. You certainly save on labor cost and speed of construction. I mean, these can be printed very, very quickly. Basically, you can have one or two or maybe three people on site during the very fast construction process, right?
Yeah, you need really at least two people. Generally, most companies have three, one for just watching for safety purposes. Depending on the printer, maybe somebody needs to manage the concrete hose. That's like a big, heavy object that's swinging around the site.
Sure.
These things can be mitigated in the future, but the technology, the mechanics are quite impressive. They're not particularly complex, though. The motors and the engines are all reliable, and the machine is accurate to like a fraction of a centimeter. And so those things, it seems like all are doing really well. One thing maybe that could have improvement is the mixing of the material to the print head. Maybe there's some room for innovation there.
But that one house that you showed us that had the walls that had the spackle on them and they had to sort of fix the job the printer did, was that a materials problem or a printer problem or both?
It was a combination of a material problem and an environment problem.
So they didn't tent the site, right? And
Correct.
So the environment. Tell us about that.
So anytime you're printing outside, you're exposed to the elements like a regular construction site. But with the printing, the concrete isn't hard when it first comes out. So if there's excessive wind or rain pelting it, it can damage the poured or the concrete that's being printed. So many companies opt to build a structure around the printer, which is obviously a huge additional cost, but it improves the build quality and the line consistency. Right. And when you have really even looking 3D printed lines, you can reasonably consider someone leaving that exposed in their home. Whereas if it's a sloppy line, that's not as easy for somebody to adapt.
Right. And of course, unless you put up drywall or do something, if the walls are raw, the way they were printed, hanging pictures is going to be a drill and a screw, a concrete drill. It's not going to be the traditional way with a hammer and a nail, of course. So a lot of differences here. And again, the whole point is speed and cost reduction. And if we've got to erect a tent around the site, it's not quite there yet. Is there any point even in considering doing these in factories and assembling them on site? It seems like that would kind of defeat the purpose.
There are many people working on that, and some people will debate whether that's more or less valid. For a small custom print like that fish we saw, it makes sense just to make that custom design in a facility where you can get really even lines.
Right.
For bigger things like a whole home, let's say a 1,000 square foot concrete home, could weigh 40 to 80 tons.
Yeah.
The printer weighs maybe 1 or 2 tons, depending. It could be even half a ton if it's one of the smaller models. So transporting that printer to the site all of a sudden makes a lot more sense for a bigger object.
Right.
I agree with you. Like the tent is super expensive and a lot of extra work, and printing off site and having to transport the materials, unless you're really close, that becomes a huge added expense.
Yeah, it's a catch-22, because with the other concept in construction and innovation, which is manufactured housing, the kit homes that you can buy on Amazon, which those are a big myth too in terms of the cheap cost. Don't be deceived. We're going to do a show on that. But maybe it'll get there. It's great to have the controlled environment of a factory, right? You've got a lot of benefits with that. But again, the point of the 3D printing is you just set up the printer, which is light and easy. Some of these big printers for big jobs can be set up with 2 guys in just a few hours. It's not very complicated. And again, there's a big difference between the robotic arm, the gantry concept, and the rails. If you do it on rails, you've got to have that track be pretty level, and that's a big job to assemble that. But if you've got a big project for a subdivision, it might be worth it, right?
Yeah, and then maybe you can put those 2 guys watching the printer to work if the printer's operating smoothly.
Fair enough. Yeah, absolutely. Okay, go ahead.
A lot of my favorite 3D printed houses incorporate different materials, like the Ashen Cabin in Cornell and these houses by Icon. 3D printing, it's cool, but to make a whole house that's entirely printed and expect somebody to just live in this entirely new concept, I think that's a little bit of a stretch. It'll take some warming up. There's all different types of houses. And one of the questions you were asking earlier is like, when are we going to see this take over the industry? I think we will see it take over its section of the industry. There's never going to be just one model of house that people want to buy, because people come in all, their opinions are as diverse as anything else in the world.
Sure.
And maybe a small fraction of the homes, the many, many billions of homes that are around the world, maybe a billion, I don't know, but if a small fraction ends up being printed, then this will be a very successful industry. To get there, I think it'll take projects like this that are partially printed and then partially using traditional construction methods. So This is Icon's printer you just saw, the Vulcan printer, and these are the 4 homes that they printed. The first floor of each home is printed in the concrete. They have their own proprietary mixture they call lavacrete. They refer to it sometimes as magma, I guess. And the lines you can see are very, very clean and
nice.
Distant. The second floors of the house are built with traditional construction. You see the zip sheath on the exterior. That's extremely common here in Texas. Pretty much every house has a zip sheath. The printed concrete, it's very strong. It has like a 6,000 PSI strength if it's the same one they were using last time. And that's more than enough to support the second floor of this house.
Is the second floor not 3D printed because of the height of the printer limitation, the printer head, or is it just the weight? It would just be so heavy by the time you got to the second story that the first story couldn't support the weight of that additional concrete.
For the Icon project, their Vulcan printer only goes high enough to do 1 floor.
Okay.
I would imagine that they're planning on raising that limitation, unless they've just become so focused on their NASA contracts that construction is like an afterthought for them, which sometimes it seems that way.
And by the way, why don't you tell us about the space application for 3D printing?
Yeah, sure. So space construction is really unique because until you build something, you can't necessarily have people outside. In the moon, you can, because there's no radiation, but on Mars specifically, there's a lot of harmful radiation on the surface of Mars. So coming up with a concept where you can build without people on site is very appealing for extraterrestrial exploration.
Yeah. And so with the Mars application, we really are talking interplanetary here, folks. So, this is the future. They would do a whole different concept there where they would potentially do these sort of inflatable structures and use the Martian Earth around them, right, to insulate from radiation, or to tell us about that a little bit. I mean, just quickly,
Yeah, that's a concept I've seen. The Mars soil is called regolith, and so they're experimenting with how to manipulate the regolith soil to be printable or malleable for construction. The one you're referring to was a project, maybe Space AI or something like that, where they had a kind of army of smaller robots pushing the soil up over a domed like air bubble or something.
Right.
I don't see that as such a realistic solution, because Elon Musk has the Boring Company, which is so effective at digging underground.
Mm-hmm.
And if you're going to just create a cave above ground, you may as well just create the cave underground. We'll see what ends up happening with that.
Yeah, we'll see. Okay.
Yeah. So here's a recent project it's designed by Mensa Corte, which is an architecture firm in Germany, using a cobalt.
And that's in Germany, right? That actual house?
Yes.
Yeah. And
you have
this,
another
by the
project,
way, is the first German house to be fully permitted for occupancy, right? It's 3D printed, right?
It's permitted for construction. I don't think they've finished it, so the certificate of occupancy is probably pending.
Okay. Well, they got the permits to do it, so yeah.
Just like Icon and SQ4D also have permits for their construction. So this is the assembly of the cobalt printer. This one takes a little more than 2 guys, but they're able to assemble it in 8 hours, disassemble it in 8 hours. This house is really unique. I call it the most innovative 3D printed house in the world, because Mensa Corte, they really got a deep understanding of the capabilities of the concrete printer they're using. And they considered a bunch of little details, and they brought like the German engineering into 3D printed construction. You can see like close up right there was a small metal flap. So when they want to have a gap for either electric or HVAC, plumbing, whatever, the printer stops its print. And after a few layers, when the gap is big enough, they just place the metal sheet over it. And the printer is able to just go right over that. Like it's a typical layer. So the human intervention, I mean, it's there certainly, but it's not hard labor like you typically see on a construction site with heavy equipment, back-breaking effort. This is just placing small objects in where they belong. Like, it looks so simple.
Yeah, it does. It does. And for those of you not seeing this, if you're just listening to the audio only version of this, of course, check out the video on our YouTube channel or the other censorship-free channels we're on as well, like BitChute and Rumble. It's pretty remarkable. The machine prints the house. They put in a few pieces of metal for power outlets, switches, etc. Pretty amazing.
Yeah, this house also has some other physical features inside that are printed. They have a printed bathtub. They have a printed fireplace. You can see here's the ICF ceiling that they're dropping in. You were mentioning concrete ceilings. So there's a picture further along where you can see how neat and organized all the plumbing and everything is on the roof. It's incredible.
Leave it to the Germans. They're the perfectionist engineers for sure. But, that's the thing people have to understand. There's a lot more to a house than just the superstructure. There's the plumbing, the electrical, there's, all of this other stuff. And that stuff can't be 3D printed. It's not like anybody can 3D print an entire house.
Yeah, that stuff certainly is not being 3D printed right now. But with all the companies printing metal and plastics and other materials, I don't think it's so hard to imagine that when the concrete walls are like at the nth level of maturity, then people will start dedicating their efforts in 3D printing to these other subcontractors.
Right, to the smaller items. Yeah, that makes perfect sense. Sum this up for us, if you would, Jarrett. I mean, how far are we away, if you can take a guess, make a prediction, from seeing commercially viable 3D printed homes? And, when we get there, will they be less expensive? How much less expensive might they be? I mean, nobody really knows for sure, but so far we're just hearing a lot of big claims that just aren't realistic.
Yeah, that's a really good question. And the answer is complicated. So economically viable homes, it's, I think, likely that the homes printed by SQ4D and Icon, I believe they'll turn a profit on those. It's a unique situation because they're the ones that developed the printer. And so they're not factoring in all of their development costs and such, but they also don't have the upfront cost of the printer and whatever premium they end up charging on the materials. So is it economically viable for somebody to just jump in and make themselves print one home? No, that's not even really possible right now, because you can't get a printer to just print one home. There's so few of them around that if you could rent one, it would be some exorbitant fee. And so it's not really economically viable for the average citizen at the moment. Now, if somebody had a big enough wallet and they wanted to do a project of 100 homes with that economies of scale, if they were able to secure materials at a large batch size for a reasonable price, then they could end up having a profitable project if they bring that scale. That could be possible right now, but because it hasn't been done, can neither be confirmed nor denied.
And as yeah, that's a good answer. And as you know, we spent a lot of time last week talking with one of the printer manufacturers. And, I got really interested in thinking I should just buy a printer, start a construction company, buy a printer, start printing affordable housing. But again, there are several hurdles left before we get there, I think, right?
Yeah, I mean, if you're deciding between a concrete 3D printer and GameStop stock, then maybe the printer. I don't know. I'm not really a stock expert, but it certainly isn't a guarantee.
Yeah, no, it's definitely not that. Anything else you want to talk about, or any more answer to my sort of big compound question I asked you about, what's next and cost and anything more there?
I'd like to ask you what you think the implications would be on the economy and real estate if all of a sudden the material cost decreased and the construction of a typical home could be 50% cheaper for 3D printing.
Well, I think, number one, that would increase the price of land, because suddenly there would be a surge in demand for land, because if the construction is now cheaper, and also people would build better houses, they would make them bigger, they would make them better, and they would use that extra available capital to do something nicer. And, hopefully it could make a dent in the homelessness problem. There's a lot of ways to make a dent in that now that just don't happen. I mean, there are all sorts of shopping centers and big box retail stores that are completely empty that could be homeless shelters, and there's all kinds of solutions. So it's not like there's a shortage of available space or anything. But it's a complex question because, there's two components in every real estate deal, right? There's the land cost and the structural cost. So if the structural cost became less expensive, that would open up a lot of opportunities. I think it would make the land cost go up on balance because there'd be more demand. And what would happen to the traditional construction industry? Would there be, massive displacement of jobs? And would the unemployment rate increase? I mean, this is the question with all sorts of automation, not just 3D printing, automated cars and autonomous vehicles and so forth, because transportation is like the world's biggest industry, and if drivers were put out of business, whether they be Uber, taxi, UPS, drone delivery of packages, there's just huge questions there as to what will happen. But so far, the interesting thing about that displacement of the human capital is that there's always been an adjustment period that maybe takes a couple of years for people to adjust and retool for different types of jobs. And if you look at the census data for the types of occupations that have disappeared over the last 50 or 100 years, there's really only one that has gone away: elevator operator. We do the do-it-yourself elevator thing now. We push our own buttons in the elevator, right? So that job has gone away, but all of the other jobs are pretty much still there. And I don't know. I think it's a pipe dream to imagine that someone driving a UPS truck can become a coder and adapt to, new technology. I'm not sure. It's a very big question. Maybe this time it's different.
Those little sheets on the concrete like we saw.
Right, but how many of those people do you need, right? Not that many, right? If I look at homes under construction nowadays, there's a whole bunch of trades and a whole bunch of people. And those trades, a lot of those won't go away with 3D printing. They'll still need people to put pipes in. Granted, yes, you can 3D print plastic, but I don't know. It's a very tough question to answer.
I think that it's different from driving, like the automation of trucking in that industry, Uber, because the infrastructure for those vehicles, like all those Teslas, could just get a software update if full self-driving was legalized and ready. And then it's instantly available nationwide. Whereas these printers, there's like at least a 4-month lead time if you want to buy one, and it requires a huge capital cost. There aren't any financing programs. Right. So it's going to be very gradual. And then also it's not all-encompassing industry. Like they can't build anything that big yet. They can't build any skyscrapers. They can't do like huge industrial complexes or warehouses. So I don't think that job displacement is ever going to be a threat for this industry, especially considering the dwindling workforce in the construction labor field. Most people are in their like 40s or 50s that are doing construction labor, and that's just not sustainable.
Yeah, no, that's true. We definitely have a graying of America and an aging population. And so with that said, a lot of those people cannot do construction jobs. Yeah, it's a very interesting industry, and we'll see what comes of it. Wrap it all up for us. Give out your website. Really, just want to say thank you for being on the show.
Yeah, thank you for having me. You can check out my website at automate.construction. That confuses people because there's no .com or anything. Maybe I should reconsider that domain. But if you'd like to also check out the houses, the 3D printed houses I've been touring, you can check out my YouTube channel. It's just my name, Jarrett Gross, on YouTube. And then feel free to leave a comment if you have any questions about a video or anything. Looking forward to hearing what anyone has to say.
All right, people, we'll keep you updated. And Jarrett, thank you so much for joining us. We really appreciate having you.
Thanks again, Jason. We'll keep in touch.
Thank you so much for listening. Please be sure to subscribe so that you don't miss any episodes. Be sure to check out the show's specific website and our general website, hartmanmedia.com, for appropriate disclaimers and terms of service. Remember that guest opinions are their own, and if you require specific legal or tax advice or advice in any other specialized area, please consult an appropriate professional. And we also very much appreciate you reviewing the show. Please go to iTunes or Stitcher Radio or whatever platform you're using and write a review for the show. We would very much appreciate that. And be sure to make it official and subscribe so you do not miss any episodes. We look forward to seeing you on the next episode.